Hi friends, welcome to my channel Magic Sir of Mathematics with Magic Methods. Today we will learn trigonometric identities based on a right angle triangle. There are basically three trigonometric identities. First, sin square theta plus cos square theta equal to 1. Second, sec square theta minus tan square theta equal to 1. Third, cosec square theta minus cot square theta equal to 1. Here theta is an acute angle. So we can write 0 degrees is less than theta is less than 90 degrees. Note that trigonometric identities are the equations. We will use them as a formula to express trigonometric ratios of an angle in terms of any one of them. Now let us prove these identities one by one. Today we will discuss the fundamental relations between the trigonometric ratios of an angle theta. In other words, we will prove an important trigonometric identity. See the figure. In triangle PQR, angle Q is equal to 90 degrees. So PR is hypotenuse. Here, angle R and angle P are acute angles. Let us suppose angle R is equal to theta. So theta is an acute angle. See the animation. Here theta lies between 0 degrees and 90 degrees. Using Pythagoras theorem, we get PQ square plus QR square is equal to PR square. This is our first equation. Dividing both sides of equation 1 by PR square, we get PQ square upon PR square plus QR square upon PR square is equal to PR square upon PR square. But we know that PR square upon PR square is equal to 1. So we have PQ upon PR whole square plus QR upon PR whole square is equal to 1. Again, see the figure. Side opposite to angle theta is PQ and side adjacent to angle theta is QR. So by definition of sin theta is equal to side opposite to angle theta upon hypotenuse, where side opposite to angle theta is PQ and hypotenuse is equal to PR. So we can write sin theta equal to PQ upon PR. Similarly, by definition of cosine, cos theta equal to side adjacent to angle theta upon hypotenuse, where side adjacent to angle theta equal to QR and hypotenuse is PR. So cos theta equal to QR upon PR. So we can write PQ upon PR is equal to sin theta and QR upon PR is equal to cos theta. Therefore, sin theta whole square plus cos theta whole square is equal to 1. This is our second equation. See the speech bubble. We have angle R is equal to theta, where theta is an acute angle. Therefore, 0 degrees is less than theta is less than 90 degrees. That is, theta lies between 0 degrees and 90 degrees. Now let us check, is this true for theta equal to 0 degrees and theta is equal to 90 degrees? We know that if theta equal to 0 degrees, then sin 0 degrees equal to 0 and cos 0 degrees is equal to 1. If we take theta equal to 0 degrees in the equation 2, then left hand side is equal to sin 0 degrees whole square plus cos 0 degrees whole square is equal to sin 0 degrees equal to 0 and cos 0 degrees equal to 1. So it is equal to 0 whole square plus 1 whole square. Therefore, it is equal to 0 plus 1 equal to 1. Now see the right hand side of the equation 2. It is equal to 1. So equation 2 is true for theta equal to 0 degrees. Again, if theta is equal to 90 degrees, then sin 90 degrees equal to 1 and cos 90 degrees equal to 0. So from the left hand side of the equation 2, theta is equal to 90 degrees. Therefore, sin 90 degrees whole square plus cos 90 degrees whole square is equal to sin 90 degrees equal to 1 and cos 90 degrees equal to 0. Therefore, sin 90 degrees whole square plus cos 90 degrees whole square equal to 1 square plus 0 square equal to 1 plus 0. Therefore, it is equal to 1. See the right hand side of the equation 2, it is equal to 1. So, this equation is true for theta is equal to 90 degrees. Hence, we have 0 is less than theta is less than 90 degrees and theta is equal to 0 degrees. So 0 degrees is less than equal to theta and theta is equal to 90 degrees. So we can write theta is less than equal to 90 degrees. Hence, we have shown that equation 2 is true for theta equal to 0 degrees and theta is equal to 90 degrees. Therefore, sin theta whole square plus cos theta whole square equal to 1, where 0 degrees is less than equal to theta is less than equal to 90 degrees. For convenience, we can write sin square theta plus cos square theta equal to 1, where 0 degrees is less than equal to theta is less than equal to 90 degrees. Note that for simplicity, we may write sin square theta in place of sin theta whole square. And cos square theta in place of cos theta whole square. Similarly, we can write tan square theta in place of tan theta whole square. Cosec square theta in place of cosec theta whole square. Fifth, sec square theta in place of sec theta whole square. And last, cot square theta in place of cot theta whole square. Remember this trigonometric identity very carefully. Now we are going to obtain the next trigonometric identity. Again, look at the equation 1. PQ square plus QR square is equal to PR square. Dividing both sides of this equation by QR square, we get PQ square upon QR square plus QR square upon QR square is equal to PR square upon QR square. But we know that QR square upon QR square is equal to 1. So we write PQ upon QR whole square plus 1 is equal to PR upon QR whole square. Now see the figure. By definition of tangent, we write tan theta is equal to side opposite to theta upon side adjacent to angle theta. But we know that side opposite to angle theta is equal to PQ and side adjacent to angle theta is equal to QR. So we write tan theta is equal to PQ upon QR. Similarly, by definition of secant, we write sec theta is equal to hypotenuse upon side adjacent to angle theta, where hypotenuse equal to PR and side adjacent to angle theta is equal to QR. Therefore, we can write PQ upon QR is equal to tan theta and PR upon QR is equal to sec theta. Therefore, tan theta whole square plus 1 is equal to secant theta whole square. This is our second equation. Now, see the speech bubble. We have angle R is equal to theta, where theta is an acute angle. Therefore, 0 degrees is less than theta is less than 90 degrees. If we take theta is equal to 0 degrees, then tan 0 degrees is equal to 0 and secant 0 degrees equal to 1. So from the left hand side of the equation 2, we take theta is equal to 0 degrees. So tan 0 degrees whole square plus 1 is equal to tan 0 equal to 0 plus 1 equal to 1. And right hand side of the equation 2, we have sec 0 degrees whole square is equal to 1 because sec 0 degrees is equal to 1. Hence, equation 2 is true for theta equal to 0 degrees, and if we take theta is equal to 90 degrees, then tan 90 degrees is undefined and secant 90 degrees is undefined. So we cannot take theta is equal to 90 degrees. Hence we have shown that 0 degrees is less than theta is less than 90 degrees, where theta is equal to 0 degrees. So we write 0 degrees is less than equal to theta, but theta is not equal to 90 degrees. So we write theta is less than 90 degrees. Therefore, tan theta whole square plus 1 is equal to sec theta whole square, where 0 degrees is less than equal to theta is less than 90 degrees. For convenience, we write tan square theta in place of tan theta whole square and sec square theta in place of sec theta whole square. Therefore, tan square theta plus 1 equal to sec square theta, where 0 degrees is less than equal to theta is less than 90 degrees. Remember this trigonometric identity. Now we are going to obtain the next trigonometric identity. Look at the equation 1. Dividing both sides of this equation by PQ square, we get PQ square upon PQ square plus QR square upon PQ square is equal to PR square upon PQ square. But we know that PQ square upon PQ square is equal to 1. Therefore, 1 plus QR upon PQ whole square is equal to PR upon PQ whole square. Now see the figure. By definition of cotangent, cot theta equal to side adjacent to angle theta upon side opposite to angle theta, where side adjacent to angle theta equal to QR and side opposite to angle theta is equal to PQ. Similarly, by definition of cosec theta equal to hypotenuse upon side opposite to angle theta, where hypotenuse equal to PR and side opposite to angle theta is equal to PQ. So we can write QR upon PQ is equal to cot theta and PR upon PQ is equal to cosec theta. Therefore, 1 plus cot theta whole square is equal to cosec theta whole square. This is our second equation. Now see the speech bubble. We have angle R is equal to theta, where theta is an acute angle. Therefore, 0 degree is less than theta is less than 90 degrees. If we take theta is equal to 0 degrees, then cot 0 degrees is undefined and cosec 0 degrees is undefined. Therefore, theta is not equal to 0 degrees. Again, if we take theta is equal to 90 degrees, then cot 90 degrees is equal to 0 and cosec 90 degrees is equal to 1. Therefore, from the left hand side of the equation 2, 1 plus cot 90 degrees whole square is equal to 1 plus cot 90 degrees equal to 0, 1 plus 0 equal to 1. And right hand side of the equation 2 is cosec 90 degrees whole square is equal to 1 because cosec 90 degrees is equal to 1. Hence we have shown that 0 is less than theta is less than 90 degrees, where theta is not equal to 0 degrees. So we write 0 degrees is less than theta, but theta is equal to 90 degrees. So we write theta is less than equal to 90 degrees. Therefore, 1 plus cot theta whole square equal to cosec theta whole square, where 0 degrees is less than theta is less than 90 degrees. For convenience, we write 1 plus cot square theta in place of cot theta whole square and cosec square theta in place of cosec theta whole square. Hence, 1 plus cot square theta equal to cosec square theta, where 0 degrees is less than theta is less than equal to 90 degrees. Remember this trigonometric identity very carefully. Let us recall the trigonometric identity which we have learned today. First identity, sin square theta plus cos square theta equal to 1. Sometimes we have to use sin square theta or cos square theta to solve the example. Sin square theta equal to 1 minus cos square theta, where sin square theta remains as it is, 1 remains as it is. Let us change the side of the cos square theta from left to right. So plus cos square theta changes to negative cos square theta. Therefore, sin square theta is equal to 1 minus cos square theta. Similarly, we can write cos square theta is equal to 1 minus sin square theta. Here, cos square theta remains as it is, 1 remains as it is. Let us change the side of the sin square theta from left to right. So, positive sin square theta changes to negative sin square theta. So, we can write cos square theta is equal to 1 minus sin square theta. These are three different forms of our first trigonometric identity. We can use any one of these formulas to solve the example or to verify the trigonometric identities. Look at these different forms of the first identity, sin square theta plus cos square theta equal to 1, sin square theta equal to 1 minus cos square theta, and cos square theta equal to 1 minus sin square theta. Sometimes we will use these formulas from the right hand side to the left hand side. See the animation, sin square theta plus cos square theta equal to 1. So we can write sin square theta plus cos square theta in place of 1. See the animation, Sin square theta is equal to 1 minus cos square theta. So we can write sin square theta in place of 1 minus cos square theta. Again see the animation. Cos square theta equal to 1 minus sin square theta. So we can write cos square theta in place of 1 minus sin square theta. These are 6 different forms of trigonometric identity sin square theta plus cos square theta equal to 1. Let us recall the trigonometric identity 1 plus tan square theta is equal to secant square theta. Sometimes we have to use the value of tan square theta or 1 to solve the example. We can write tan square theta is equal to secant square theta minus 1. Here tan square theta remains as it is. Sec square theta remains as it is. Let us change the side of 1 from left to right. So plus 1 changes to negative 1. Hence we have tan square theta is equal to sec square theta minus 1. Similarly, we can write 1 equal to sec square theta minus tan square theta. Here sec square theta remains as it is. Let us change the side of 1 from right to left. So negative 1 changes to positive 1. Again, let us change the side of tan square theta from left to right. So positive tan square theta changes to negative tan square theta. So we can write 1 is equal to sec square theta minus tan square theta. These are 3 different forms of 1 plus tan square theta equal to sec square theta. Look at these different forms of the identity 1 plus tan square theta is equal to secant square theta, or tan square theta is equal to secant square theta minus 1, or 1 is equal to secant square theta minus tan square theta. Sometimes we will use these formulas from the right hand side to the left hand side. See the animation. 1 plus tan square theta equal to sec square theta. So we can write 1 plus tan square theta in place of sec square theta. Similarly, tan square theta equal to sec square theta minus 1. So we can use tan square theta in place of sec square theta minus 1, and 1 is equal to sec square theta minus tan square theta. So we can write sec square theta minus tan square theta is equal to 1. These are 6 different forms of the identity 1 plus tan square theta equal to sec square theta. We can use any one of these formulas to solve the examples or to verify the trigonometric identities. Let us recall the trigonometric identity 1 plus cot square theta is equal to cosec square theta. Sometimes we have to use the value of cot square theta or 1 to solve the example. We can write cot square theta is equal to cosec square theta minus 1. Here cot square theta remains as it is. Cosec square theta remains as it is. Let us change the side of 1 from left to right. So plus 1 changes to negative 1. Hence we have cot square theta is equal to cosec square theta minus 1. Again, we can write 1 is equal to cosec square theta minus cot square theta. Here, cosec square theta remains as it is. Let us change the side of 1 from right to left. So -1 changes to +1. Again, let us change the side of cot square theta from left to right. So plus cot square theta changes to negative cot square theta. Hence we have 1 is equal to cosec square theta minus cot square theta. These are three different forms of 1 plus cot square theta equal to cosec square theta. Look at these different forms of 1 plus cot square theta is equal to cosec square theta. We can write cot square theta is equal to cosec square theta minus 1. Similarly, we can write 1 is equal to cosec square theta minus cot square theta. Sometimes we will use these formulas from the right hand side to the left hand side. Here 1 plus cot square theta equal to cosec square theta, see the animation. So we can write 1 plus cot square theta in place of cosec square theta. Second, cot square theta equal to cosec square theta minus 1. See the animation. So we can write cot square theta in place of cosec square theta minus 1. And last, 1 is equal to cosec square theta minus cot square theta. So we can write cosec square theta minus cot square theta is equal to 1. These are 6 different forms of 1 plus cot square theta equal to cosec square theta. I have given screenshots of the proof of each identity in the at a glance section. You will never find false claims for cheap popularity in my video. Here you will learn pure mathematics without any drama. Now enjoy the video till the end.